Hi everyone! Today we'll be presenting our project, ModuMeal. Our project focuses on improving the experience of meal planning, especially for people who are trying to follow specific nutrition goals, like building muscle or losing weight. We wanted to create an app that allows for a more personalized experience, since meal planning is highly dependent on specific user needs. We approached this as an interaction design problem, rather than just a food or fitness problem. We found that current applications did not allow the kind of flexibility needed for users to create a meal plan with efficiency and ease. One of the biggest challenges users face is not knowing what to eat on a daily basis. Even when people do understand nutrition, the actual process of deciding meals becomes repetitive and mentally exhausting. Users have to constantly make decisions like what to eat, how much to eat, and whether they'll actually enjoy the meal. Over time, this creates decision fatigue, which often leads to inconsistency and burnout. We looked at existing solutions such as calorie tracking apps and recipe-based platforms. For calorie tracking apps, users are required to manually input everything they eat, and this violates the heuristic of recognition over recall since users need to remember and log their meals constantly. It also reduces efficiency of use because the process becomes repetitive and time-consuming. For recipe-based apps, meals are presented as fixed outputs. This limits user control and freedom since users can't easily modify individual components without restarting the whole process. Overall, current systems are rigid and do not match how users naturally make decisions about food, nor do they provide flexible options to cater to individual user needs. From this analysis, we developed a key insight. Meal planning should be flexible and modular rather than fixed and recipe-based. This insight ultimately allowed us to come up with a concept for our product. Our solution is ModuMeal. It's a modular meal planning system that allows users to build meals based on interchangeable components, such as protein, carbohydrates, and vegetables. The goal of this app is to reduce cognitive load and make meal planning feel more intuitive and adaptable. Users can achieve goals such as discovering meals, planning meals, and editing existing recipes to meet their needs. Ultimately, ModuMeal takes into account fitness goals to help guide users in the right direction. The first problem we address is that users don't know where to start. We solved this through goal-based onboarding. The user will first be prompted to input demographic information, such as age, weight, and height. Users then select their goal, such as building muscle or losing weight, and the system uses this to guide their meal planning. This supports the design principle of matching the system to the real world, since it aligns with user intentions and expectations, generating results that reflect their personal goals. The core interaction in our system is the modular meal builder. Users can select components like protein, carbs, and vegetables to construct a meal. A key feature is that users can easily swap ingredients without restarting the entire process. This supports user control and freedom since users can make quick adjustments. It also improves flexibility and efficiency of use. It reduces the gulf of execution because users can directly manipulate meal components instead of navigating complex steps. The next issue is that planning meals across multiple days can be time-consuming. We address this with a weekly planner that allows users to organize meals quickly. This supports recognition over recall since users can reuse and select existing meals rather than starting from scratch each time. Meals can be organized by breakfast, lunch, and dinner so that users know exactly what they will be preparing throughout the day. This feature works to lessen the user's cognitive load as they don't have to rely strictly on memory for meal planning. Another challenge is the disconnect between planning and execution. Our system automatically generates a grocery list based on selected meals. This improves visibility of system status and reduces friction by connecting different steps into one flow. Rather than having the extra step of writing down a grocery list, the user can quickly access a list of the ingredients they need to cook their meals. Users can check items off the list as they shop or to eliminate items that they already have. This feature allows users to keep track of ingredients without having to search through each recipe. The full interaction flow begins with goal selection, followed by meal construction, weekly planning, and finally grocery list generation. Each step is designed to reduce cognitive load and streamline decision making. Overall, the system minimizes unnecessary steps and keeps interactions direct and intuitive. Our design improves usability in several ways. It supports recognition over recall by presenting structured options. It enhances user control and freedom through easy ingredient swapping. It reduces the gulf of execution by allowing direct manipulation of meal components. And it maintains visibility of system status through clear feedback in meal composition and grocery lists. However, there are still limitations or trade-offs to our system. The system may oversimplify nutrition for advanced users who need detailed tracking. It also depends on a predefined ingredient system, which might limit flexibility. Additionally, new users may need some time to adjust to the modular interaction model. In conclusion, ModuMeal rethinks meal planning as an interaction problem. By shifting from fixed recipes to a modular system, we create a more flexible and user-centered experience. This improves efficiency and creates an overall feeling of directness that might not be achieved through current meal planning applications. Thank you.